So hello. On my speaker notes here, I've got an introduction, but that's already been done. This talk is Productive Duct. I guess I should mention I'm currently working as a freelancer contractor in London. I'm available for hire. And my name and who I am has already been covered. So without further ado, let's go on to Productive Duct. So this is about Duct, which is a data-driven framework. But I'm also going to talk about Arachne in this talk, which is another data-driven framework. And this was Luc van der Hart gave a presentation on Arachne last year at this very conference. In fact, this conference has Duct has a long history with this particular conference. In 2015, 2 years ago, almost to the day, I presented Duct Covered, which was the first presentation I did on Duct. And at that point, Duct was a lining and template, and it was expressing how I thought a closure web application should be structured. But it wasn't really anything more than that. And as 2015 wore on, and I talked to various people about the template, I started to think maybe it could be more data-driven. And at the same time, Arachne was being worked on, and that was also, there were sort of rumors and talk about it also being data-driven. And I was thinking, well, this is really the direction I wanted to go in. But I didn't know how to get there, so I meandered. From 2015 to 2016, I tried various experiments. Duct got a little bit more data-driven. It got a main configuration file, which drove the whole application. I wrote some more libraries for it, but I didn't really have a clear idea of where I was going. And then in 2016, there was a presentation at this conference, Arachne Building a Framework in Closure by Luc van der Hart, who is the lead developer on Arachne. And this had a single idea that crystallized where I wanted to go in Duct. So Duct, or the current version of Duct, owes a lot of inspiration to Arachne. And throughout this talk, I'm going to be talking a little bit about Arachne and how it compares to Duct. Or at least the new design of Duct. And that leads us to today with Productive Duct. So I talked about there being a key takeaway in Luc van der Hart's presentation, a key idea that really hammered home what I wanted to do with Duct. Like, it was kind of, I used the term revelation. It wasn't quite that, but there have been a few talks that I've listened to that have really crystallized my thinking at the time. So Rich Hickey's Simple Made Easy. Before I watched that, I had a very nebulous concept of what it meant to have a good program. And then when Rich came along and said, okay, well, it's about simplicity, and simplicity was about reducing complexity, that crystallized what I'd kind of already been sort of reaching for. Right? Somebody smarter than I came along and said, okay, well, this is actually how you do it. And I was, had figured out enough that I could see that was the right way. Building a framework in Closure was another talk where I had that sort of same realization of, oh, okay, this is how we do it. And the idea that Luc presented, almost as kind of like a throwaway thing at the beginning of the talk, was that you can think of a code base as a tree. And this isn't particularly a new idea. We all know about abstract syntax trees and the idea of a code base being a tree where you have a sort of main method, you fall out into branches. That kind of feels quite intuitive. And in this model, the libraries are essentially you're replacing the branches of the tree. So instead of writing your own stuff, you have a library which you call indirectly, and it's written by somebody else. And you start off with your trunk, and you kind of put these branches onto the tree from other people. So if libraries are the branches of a tree, then the trunk of a tree is what a framework is. So a framework replaces the trunk of a tree, whereas the libraries replace the branches of the code tree. So once we have this kind of simple idea of what a framework is, we can start asking questions. So this is a fairly straightforward definition of what a framework is, but I find that good, simple definitions are important to learning and discovery. If we can define something precisely, in the same way that Rich Hickey defined the word simple and define how simple relates to software development, by defining the frameworks as being the trunk of a tree, we can start to ask questions and get intelligent answers about it. Like, for instance, how do we represent the trunk? So a framework replaces a trunk. Well, how do we represent this structure? And there are various ways. And every framework represents this in a different way. Ruby on Rails and Django and other frameworks of that ilk use a file system a lot. They also use classes, object trees. They sometimes have some kind of custom file format, usually in like routing. The Play framework for Scala and Java has like a custom routing file, which is kind of where everything kicks off from. Spring uses XML, or used to use XML before it moved on to annotations. And all of these, in a lot of frameworks, they're kind of a hodgepodge of ideas. Ruby on Rails and Django kind of use the file system, but they also use the class hierarchy a bit. And they also use custom file formats. It's not, there's no kind of real clear indication of where things start and where things end. So maybe we can do better. Maybe we can have a very clear definition of where the framework starts and where it ends. And so we can change this question. We can say, okay, well, how do you represent the trunk? How do you represent the trunk in Clojure specifically? Right? If we were going to build a framework in Clojure, would it look like the kind of frameworks we build in Ruby or Python, or would it look like the frameworks we build in Java or even Haskell? And I think how you build the framework comes down to the question of how you define the structure of the trunk of your code base. And in Clojure, as with so many questions, the answer is kind of obvious. And that's use data. So a lot of questions in Clojure, the answer is data. And, but just saying, okay, well, the answer is data doesn't really tell us a lot. How do we represent this data? And Arachne represents it as a database. Specifically, it uses either Datomic, an in-memory Datomic database, or data script. And it's an immutable database, or it can be immutable. You take snapshots of it. It's a very kind of Clojure-y solution, very kind of Cognitect solution as well, since they're pushing, or they're sort of leading development of Datomic. And it makes sense to, in context of Clojure, to base the structure of an application around a database which you can take immutable snapshots of, and it has history, etc. So if Datomic is a very Clojure-y database, then using Datomic as the trunk of the tree is a very Clojure-y way of writing a framework. So Duct takes a slightly different approach. Duct takes the other path. The other way of representing data is not to use a database, but to use a data structure. And in fact, it uses an immutable map. So the first way that Duct differs from Arachne is it uses a data structure, an immutable map, instead of Datomic. It also differs from Arachne in a slightly different way. So this is, I'm just going to explain briefly, and probably inaccurately, the build chain of Arachne. So how does Arachne go from having a configuration down to having a running system? How does it build the system? What is the trunk of Arachne's tree? And Arachne starts off by having some scripts that configure the database. So it has a bunch of configuration scripts. These configuration scripts insert entities into the Datomic database. Then it takes the database, and the database entities are turned into a system of components. That's using Stuart Sierra's components. So it leverages Stuart Sierra's component library, and it creates a running component system from the database entries in the in-memory Datomic database. Once it's got that, it starts the resulting system. So integrand has a slightly simpler, or Duct has a slightly simpler view, and it uses a tool called integrand. So if Arachne is based on component, Duct is based on integrand. It's kind of like the core of the system. And integrand has a simpler run chain. It's a simpler tree. It reads in a configuration, and the configuration is just in Eden, so it doesn't use a configuration script. It just has a Eden configuration. And then it has an initiate method, or init, which turns the configuration into a running system. And it doesn't bother having this intermediate step of turning the data into components and starting the components. It just turns the data directly into a running system without any intermediate solution. By having integrand as like a custom solution, which is designed for this kind of style, it can remove a lot of the kind of overhead that's, or not overhead, but complexity that's going from the database to component and then starting the system works. So integrand is kind of like the core of the system. It's the sort of heart. If Duct is the vocabulary of the system, integrand is its grammar. So Duct adds in this additional prep step, and this is kind of necessary because it allows transformations of the configuration map. One of the things that Arachne's configuration scripts allow is that they allow complicated entities to be inserted into the database using very concise syntax. And the preparation stage, which Duct introduces, is a way of doing that. So integrand just has read init, and that's just a kind of like a chain. It just reads the configuration in, it initiates the configuration, and Duct introduces this prep step, which transforms the configuration in some way. Duct also adds in a bunch of libraries. So that's the kind of difference between integrand and Duct. Integrand is like the more stable basis. It's the grammar to the vocabulary that Duct has. And I wanted to separate them out because it's useful. Integrand is useful on its own if you don't want to use Duct. So it's useful. Lots of people, I think more people are using integrand than people are using Duct right now. So I'm just going to briefly sort of talk about integrand and how that kind of fits into Duct. So I'm a big believer in any tool that can be described on the back of an envelope. This isn't really a trait shared by many frameworks. When I started researching this talk and I tried to find simple explanations of quite a lot of frameworks, ones I didn't know about. So I've used a few frameworks in my time, but it turns out there's quite a lot more frameworks out there. And trying to get short explanations of a wide variety of frameworks is quite hard. So with integrand and Duct, I wanted to have a very simple explanation. I wanted to be able to have a configuration which you could look at and say, or a framework which you could look at and say, okay, well, this is how it works. You can explain it in a few steps. So I'm going to attempt to do that now, and hopefully it'll all make sense. So integrand has about 3 rules. The first rule is configurations are maps. I kind of already covered that. So here we have a configuration. It has a key and a value. Not a particularly useful configuration, but for brevity's sake, that is probably the simplest configuration you can have. And the keys must be namespaced keywords. So it's a map with namespaced keywords. The second rule is each map entry can be initiated. And initiated means it has an associated multi-method called init key. And this multi-method takes in a key and a value and returns a new value. So in this case, it just adds 1 to the value. So perhaps not unsurprisingly, if we take this configuration and we initiate the configuration, it applies this init key method to each value, or each key map entry, and we get out foo a equals 2, because we've incremented it by 1. So hopefully that should be fairly straightforward. And the third rule is refs are replaced with initiated values. So these are integrand refs. They're different from closure refs. I'm reusing the word because we've only got so many words in the English language. Sometimes we do need to reuse words in programming. So an integrand ref, IG is the usual abbreviation I use for integrand. This ref refers back to this key here. And we've got 2 multi-methods, one for A, one for B. A gets increments the value by 1, and B doubles it. So now when we initiate the configuration, it first looks through and looks at these references and says, OK, well, B depends on A. So therefore, I need to start A first. I need to initiate A first. So the first thing it does is it takes A, which is 1, increments it by 1, gets 2. Then once it's got this, this reference is replaced by the initiated value. So this becomes 2. And then we double 2 to get 4. And that's essentially all integrand does. Running out of time a little bit, so I will hurry up. Just going to go a quick word on keywords. So who here has actually used the derive method in Clojure Core to create keyword inheritance? 1, 2, 3, 4, 5. 5 out of the audience. So yeah, it's not commonly used, but it's super useful under the right circumstances. So I'd like to ask, what's in a name? Like why do we use keywords as names? Like what is a name? Why is it useful? Well, the first thing a name can be is it needs to be a unique identifier. If a name isn't unique in computer science, it's kind of useless. Usually we want it to be unique in some kind of context. But if uniqueness is our only design constraint, why don't we just use UUIDs or randomized word pairs? It's not enough for a name just to be unique. Usually the name also has some semantic information. So when people refer to the database of the application, they're referring to something specific. They're referring to an actual specific database. But the name itself, the database, has semantic information. We're conveying to people that this is some kind of database, a specific type, but one that somebody, even without knowing the system, can infer. Keywords have hierarchies, as mentioned before. So in Duct, it's a little bit hard to see this because the purple, this is kind of meant to be a reddy color, but in the projector it's coming out purple. Duct has a key called Duct server HTTP Jetty, Jetty HTTP server. This is derived from Duct server HTTP, which in turn is derived from Duct server, and that in turn is derived from Duct daemon. This is like a single inheritance tree, but keywords can also have multiple inheritance. So you can also have additional keys. We can say, okay, well, this inherits from the loggable key, inherits from sync, and it inherits from async. So we can say that this is not only a HTTP server and a daemon process, but it's also loggable. It supports synchronous handlers, synchronous string handlers, and it supports asynchronous string handlers. So we can use keyword hierarchies to convey semantic information about a particular keyword. We can query the configuration and ask questions about it. We can say, okay, well, what are the HTTP servers in this configuration? Are they loggable? Do they support asynchronous handlers? we can start to ask intelligent questions about this and get intelligent answers, which we can't do with a normal piece of code, right? We can look through the code, we can do some analysis of it, but we can't ask full questions and get foolproof answers without having a human involved. You can't take an arbitrary piece of code and say, okay, well, what service does this run? So integrand has this idea of having regular keywords. So this is a quick example of how you'd set up a web server. So we have a handler which has a reference and we have a port number. We also have this thing called composite keywords, and this is just a shortcut way of doing inheritance on the fly. So by having these two keywords in this vector, we're saying create a new keyword that derives from all of these values. And that's useful for making unique stuff. So if you have multiple databases in your application or multiple web servers, then you can assign them a unique name. It's also used for a few other things, which I'll get on into the demo. So one more thing before we go to the sort of live coding exercise is modules. So modules are things which are applied at the preparation stage. They're pure functions. They have dependencies attached for ordering. So they're pure functions, they have dependencies attached for ordering purposes, and they transform the configuration. So modules are just essentially pure functions which we apply to the configuration, we get some kind of transformation. And to show you a kind of simple example, you might have a module which is just a key, and it's got nothing in there because you're just doing default values, we're not configuring it anyway. And this is what a full configuration might look like before the prep stage. Then once you run the prep stage and apply the modules are kind of expanded out. So this module itself adds these additional keys to the configuration. You can think of them as macros for configurations. They're things that have a small bit of code to expand out into a larger bit of code. They're the only things which can add in multiple keys. And this kind of replaces the configuration scripts in Arachne. So let's go on to a live coding exercise. And this will be my first live coding exercise. I've been told we've got 5 minutes, so it'll be a short one. This will be, which is good, because this is the first live coding exercise I've had in front of an audience. I'm sure nothing will go wrong. So let's see if we can get this. Yep. It's not switching. Not switching desktops. It's okay. Something has gone wrong already. Let's just quit this and start it up again. Okay. Okay, excellent. So let's be super quick with this. Can everybody see that? Okay. That is one I made earlier, but let's do one from scratch. So this is, I'm just going to create a quick Duct application. I'm going to say it's, I'm using a Lineagen template, so I'm going to say it's an API. I'm using an Ataraxy web router, which is kind of like an alternative to Composure. And we're just going to use a SQLite database. Line new Duct. So we go into here, do the setup process, and this creates a bunch of local files. load up the project file. Let's just zoom into that. We'll add in an additional dependency. So it adds in a bunch of dependencies here. It's going to add in a quick additional dependency. We're going to use Cider to connect to it. Should, in theory, there we go, we're connected. So this gives us a REPL process. Load up the dev namespace. And this step is here just so that it will always load up even if you have errors in your dev namespace. Then we use Go to start the system. And we've started the server on port 3000. Might be running a little bit over time here. Okay, is it? Okay, okay. I might be a few minutes over if that's okay. Okay. Right. So let's just check it's working. So we'll just do a HTTP call to port 3000, which is where it started on. We can see we've got a not found HTTP, which is fine. We haven't added any routes in yet. So let's add in a route. So we'll go to the configuration. So this is what the configuration looks like. And you can see we've got a bunch of modules here. We've got a logging module, an API module, and a SQL module. And then we've got a module for the routes here. It's a production environment by default, but since we're loading up in development, it's actually the development environment. And the project name is just foo. So let's add in the default route. So we'll say, OK, we want to get route, and we will say, OK, well, we'll go to index. And we'll use these composite keywords to create a static handler. And we'll call the static handler foo.handler/index. And then this is connected implicitly to here. That's what this module does. This interacting module connects this index page implicitly to this thing here. So you'll say body, and we'll just give it a quick link. Save it. And we can do one of two things here. We can go back to the refresh or the REPL. We can hit reset. And this reloads all the files. I've also bound this to a key on my editor, so I just need to hit a particular key combination on my editor, and it automatically reloads the project. So we now test the main value here. We can see it's now coming out with a handler. We haven't written any code at this point, we're just using the configuration. So I'll just do one more thing to sort of demonstrate, bearing in mind the time. We also had this handler, or a SQL handler. So let's put in a small value. So let's say get to-dos. And we'll say to-dos/list. SQL handler, foo.handler.todos/list. And we can give this some SQL to execute. But before we actually execute any SQL, we actually need to add something to this database. So we will add in a migration. So we've just got a brief, we've got a migration here. And again, we're going to use composite keys. And we're going to say, okay, up, we want to just create a table. Table to-dos. Key and a description, some text, and a down migration. And once we've got this migration, if we run reset on the application, it runs an error, but clearly something has gone wrong. Oh, okay, yes, this is an actual key. This needs to be replaced with a slash because it's dot dot and then slash. Okay, so there's a small syntax error there. And now if we reset, it errors again. So what I'm going to do now, because in the interest of time we don't actually have time to debug this, we certainly have a lot of time, I'll just go to a brief one I made earlier and show you the configuration there and then end the talk. If I could actually see. This worked so well before. Okay, so this is the full configuration, and this is what I was trying to do. And for some reason that this is the correct syntax, and the syntax I did before was somehow incorrect, but I don't have time to debug it. But running this full configuration allows you to define a configuration mostly through the full application, mostly through the configuration. Unfortunately, I ran out of time, but I'd be happy to show this to anyone later on in more detail, perhaps over a beer or two.
Thank you, James. Thank you. We're going to skip questions for now, but there's plenty of time. And James is also on the panel this evening as well, so you've got plenty of chance to talk to him. So we're going to come back a bit later. Come back at 20 past, and then hopefully Hugo is here. Is Hugo here? Yay, Hugo's here. So we'll do some more web stuff as well. Again, thanks very much, James. Big round of applause.